Hi everyone, I'm back with another Create.3 video, and this time I have a really cool smart storage system for you to see. Just yesterday, I discovered that sequenced gearshifts allow us to dictate specific programs for our pistons and motors. And as soon as I learned how they work, my mind jumped to a configurable storage system. You make a selection, and as soon as the button is pressed, the system retrieves the chest that you requested. Then you simply press the return button and the system will put it back in exactly the right spot. You can expand this system by as much as you'd like, and you can also apply the concepts used here to a horizontal system. So now that you have a general idea about how this works, let's get into the details. But before we do that, I want to remind you that if you're new to Create.3 and maybe think that this looks a bit too complex, you can go ahead and check out my redstone and my building tutorials for Create. And of course, subscribe to my channel to see me build more things and teach you how to build them. I currently have two creative motors running this system, and they're set to 128 rounds per minute. This one up here is connected to this series of gearboxes. On this vertical line, I have this set of alternating gear shifts that ensure that everything is rotating in the same direction. And I have the same thing set up on the opposite side, which is powered by a second creative motor. And we'll get to what these do a little bit later in this video. Down here, we have this series of gearboxes connected to a series of sequenced gearshifts, which are essentially the heart and soul of this system. Each one of these gearboxes tell the vertical piston to go up a certain distance, wait for 1 second, and then come back down. In order to expand this system, these need to be duplicated with alternating directions. Since you can reverse the direction and change the speed of these sequenced gearshifts, I didn't bother with regular gearshifts to match the rotation down here like I did with the vertical setup. All of the sequenced gearshifts relay their power to this chain of gearboxes, which connect to the vertical piston. This way, whenever one of these sequenced gearshifts receives a redstone signal, it can relay its instructions to the piston without any overlap with the other sequenced gearshifts. And now it's time to look at our horizontal piston, which is the one that retrieves and returns the chests to their spots. The horizontal piston is placed on a layer of sticky chassis with two sequenced gearshifts that are always attached to the piston. This sequenced gearshift is responsible for retrieving chests, and this one is responsible for returning them, which is why we have these two observers pushed by pistons here to only enable one of these gearshifts at a time, depending on what we need to do. And I went with observers because I discovered that they send a redstone pulse whenever the system stops, which is exactly what I needed. So when the vertical piston gets to be next to one of these chests that need to be retrieved, this horizontal system only has 1 second to do what it needs to do. The retrieval sequence is simple. The piston is set to retract, wait for 1 second, and then expand. So when we're retrieving, it will retract, pulling in the chest, and then it won't have enough time to extend again because the vertical system will start moving. Now when it hits the ground, it will go through the same sequence again. First it will want to retract, but it's already retracted, and then it will wait 1 second, and finally it will extend and deliver the chest to us. The return sequence is much simpler. It extends the piston by 2 meters and stays out. This is the only way I found to spit out the chest and leave it in storage, and after that, the system will just return to rest. And now it's time to look at the coolest part of the system, which is the memory portion. This very simple memory makes sure the system remembers which chest we called so that it can be returned to its proper spot without any manual effort. Before I added this memory, I had to press the return button and then press the color again to return the chest to its right place, and that was just inconvenient. So let me show you what happens when we make a selection. Obviously, you'll see everything we discussed happening with the chest being retrieved and brought down here, but on this other side, you'll also see that we have a chain of powered latches connected to the same buttons. So whenever we press a button, the corresponding latch will come on and stay on. So the system now knows exactly what item we have. Let's go ahead and look at the return circuit, and then we'll see how the system uses this memory feature. Pressing the return button does a few things. First, it will power this latch on, which saves the state of the system. Then we have this redstone link, which tells various parts of the system to get in return mode. As I mentioned before, these pistons will move, placing the observer next to the sequenced gearshift responsible for returning items. But on this side, we have the same redstone link sending a pulse to the side of each one of these powered latches. And since powered latches that are off don't respond to a signal from the side, the only one that will respond is the one that's on. This will toggle this torch on and send a signal through the redstone link, which will in turn activate the sequenced gearshift that will send the vertical system back to the correct spot. Hopefully, this has not been too confusing. These observers here serve a very simple purpose. They tell our system that we're done returning an item, and so they turn on the retrieve mode using a redstone link. This was another portion that was manual at the start of the project, and I found an easy way to automate it. As you see, the chest is returned to its proper location, and the system is reset back to retrieve mode. So we can simply call another chest right away. I think this system has been the most fun thing I've built so far. I personally like it a lot more than the cart assembler storage system that I built before, but I think both concepts can be developed to be a lot cooler. Let me know what you think about this storage system. And if you'd like to try it for yourself, go ahead and download the NBT schematic that's linked in the description. Thank you so much for watching, and I will see you in my next video.